Okay, quadratic function is a function that can be written in the form y equals ax squared, where a cannot equal 0. So what that means is anytime you see the x squared portion of that, that's what makes it quadratic. If you have just an x, that's linear. Okay, so that's why a cannot equal 0, because if it's 0, then you don't have an x squared term. It's not quadratic. The U-shaped graph of a quadratic function is called a parabola. So remember that quadratics are very similar to absolute value functions. The absolute value function was a v, and quadratics are u. Okay, but they have very similar attributes. Okay, the vertex of a parabola is the highest or lowest point of the graph. It's also the center of the graph. The axis of symmetry is the vertical line that passes through the vertex and cuts the graph in half. It's a vertical line, so it's always going to be x equals a number. Okay, so your parent function for quadratic functions is y equals x squared, or f of x equals x squared. Remember that f of x and y are interchangeable. F of x is just your function notation. But other than that, there's nothing specific about the difference there. So what we're going to do is this first lesson, we're going to use our calculators to look at the tables. We're going to do the tables and then look at vertex, axis symmetry. We're going to determine if it's a maximum or minimum. We're going to look at the transformations and do domain and range. Okay. So to start with the table for your parent function, we're going to go to our calculator, which hopefully it should be cleared. If it's not, just doc B it. Okay. If you're in your scratch pad, if you hit that calculator button one more time, that gets you to the graph that you need. Okay, and that f1 of x is just your y1. Okay, so all you have to type is your x, and then the squared button is right next to the 4. So x squared, enter. And that is what the parent function of a quadratic function looks like. So it's got the u, the vertex is right here, the center of your graph. Okay. Just like with absolute value function, the vertex is going to go in the center of your table. Okay, so to get my table in the calculator, you can do Control T. Now you do not have to hold the control button. It's not like a computer. Just press Control and then hit the T for table, and that should split screen with the graph on the left and your table on the right. Okay, so we're going to scroll. You can see your points right there. Okay, y'all all good with the buttons that I pressed and how to graph?
I'm sorry, could you please repeat how to pull the graph? I mean, Control T.
Control T gets you your table.
The letter T.
So we're going to put our vertex in the middle, and then 2 above and 2 below, just like we did with absolute value. So I've got negative 1, 1, negative 2, 4, 1, 1, and positive 2, 4. Okay, do you notice anything about the y values of the table? Okay, they're all positive. Huh? They're repeating. So that is the key about the vertex. Your y values should repeat around that vertex. You're going to have to be able to identify the vertex without anything at some point. Okay, so we're going to work on that today. But that attribute right there in your table, everything mirroring around that vertex, is the key to knowing if you got the vertex right or not. Okay, so we're going to graph that. And then make a U-shaped graph, extend it with your arrows because it is a continuous function. So remember that it's not straight lines because that would be an absolute value function, okay? So you got to make a little curve to it. Okay, if you look at the blanks underneath, our vertex we said is 0, 0. For your parent function, it's always going to be 0, 0, the origin. Your axis of symmetry, okay, we said that was the vertical line that cuts through the vertex. We're going to graph that for every single graph. If it is a vertical line that cuts through this vertex, it's a dashed line. It's kind of hard to see because it goes along the y-axis, but it cuts it. It's like a line of symmetry. Okay, if you remember whenever you learned symmetric parts, y'all would do figures and fold them, and you'd have a line of symmetry. That's all that is. Okay, but I said it's a vertical line, so it's always x equals, and it will always be x equals the x value of the vertex. Always, because it has to pass through the vertex for it to be the axis of symmetry. So for the parent function, it's going to be x equals what? 0. Okay. Now our domain and range. Okay. Domain is the set of all possible x values for this function. Okay. So x values, that's along your x-axis. We're going to go from the left to the right. Okay. So if you look at your graph, if I look on the left side of my graph, okay, even though it's going up, I'm still going left. Do I have an end point? Because I have arrows. If I go to the right, even though it's going up, I'm still going to the right. Do I have an end point on the right? No, I don't have an end point left or right. So that's going to tell me it's all real numbers. Okay, so we're going to go back to interval and set builder notation. We're going to talk about that. Okay. Interval notation would be negative infinity to infinity. I remember that? Okay. Set builder, remember, looked like this. Okay, and what would I write for all real numbers? That XER. X is a member of all real numbers. Okay, I don't care which one you do. I'm going to do both each problem for whichever you prefer. Okay, your domain, because this is a continuous function, will be the same every single problem. Okay, so I told them earlier, if you don't get a single thing right, you should at least get domain right. Okay, because it doesn't change. It's going to be all real numbers because you're always going to have arrows on both ends. Okay, your range will change though, according to your graph. So your range is the set of all possible y values. Okay, so your y-axis is up and down. So you go from bottom to top. Okay, you always go smaller to larger. So we're going to go bottom to top. Do I have a bottom boundary of this graph?
No.
Yeah.
0. Okay, I don't go any lower than 0, so that's my bottom boundary. That's my lowest point. Okay, so I'm always going to be looking at my vertex for range. So that's my lowest point, and then I go up. Do I have an endpoint or a boundary going up? No. So I go from 0 all the way to positive infinity. So for interval notation, I'm going from 0 to positive infinity. Okay, remember 0 has a bracket because it's equal to. Or, if we do set builder notation, range is y, so it's going to be y instead of x. And we're going to build an inequality. It's going to be a simple inequality. Okay? If my boundary is at this lowest point, which is 0, my y values, are they going to be greater than or equal to 0 or less than or equal to 0?
Greater than or equal to 0.
Greater than or equal to 0. Okay? Your range, that y value, will always be the y value of the vertex because of the fact that your vertex is your highest or lowest point. Okay, good with that? Alright. Now vertex form. Vertex form for a quadratic is very similar to vertex form for absolute value. Okay, the only difference is you have parentheses squared instead of absolute value bars. Okay, so if you remember, your vertex is at HK. So whatever is happening inside your parentheses, remember that I used to say that X is a liar and that's your opposite sign. So you take the opposite sign of whatever your problem tells you, and that's the X value of your vertex. Your K is as is. So if it's negative 50, the Y value of your vertex is negative 50. If it's plus 5, the Y value is plus 5. Okay? Your vertex is still going to go in the center of your chart. We're not going to do decimals or fractions in your table unless it is your vertex. Okay? Your axis of symmetry, I said, was the vertical line, so it's X equals. And so the X value of the vertex is H, so X equals H. Okay? Now, if the number in front of your parentheses is greater than 0, meaning if A is positive, the parabola is going to open up. And it's going to look like this, where your vertex is right here. Okay. If the number in front of your parentheses is less than 0, meaning there is a negative, then that means there was a reflection and it opens down. And it would look like that with your vertex being at the top. Okay. So you have a minimum when the graph opens up, and you have a maximum when the graph opens down. Pretty much you're looking at your vertex. Is it the highest or lowest point? Okay. Also, we're going to put maximum at y equals and minimum at y equals. So your vertex is not just going to tell you your axis of symmetry. Your vertex is going to tell you where that maximum and minimum is going to be, which is the same as your range. Okay. So refresh your memory of what happens if that A is greater than 1. Then that means what transformation? Do y'all remember? That's a vertical stretch. Okay. Now, we're going to do by a factor of, which is going to be your A value. Okay. We didn't do that with absolute values, but we're going to do that with quadratics. So each time we're going to do the vertical stretch by a factor of blank. Okay. Here, if your A value is between 0 and 1, meaning a decimal or a fraction less than 1, then that's going to be a vertical shrink. Okay. What about, we talked about if it's negative, you have a reflection. What does that K value tacked on do? Do y'all remember? It shifts it up or down. If k is positive, it shifts it up. If it is a minus, it shifts it down. Your h, that's an h, shifts it left or right. It's affecting your x. Remember, x is a liar, so if your formula or your equation has a plus, you're really going left. If it has a minus, you're really going right. So you have to be careful with your horizontal translations. You good with that? Okay. All right, so for these first two examples, all we're doing is making a t-chart. Okay, I want you to be able to identify your vertex before we go to the calculator and do our t-chart though. Okay, so if I'm looking and comparing this to my vertex form, y equals a times x minus h squared plus k. If I'm comparing that to identify my vertex, what's my vertex for example 1? Do I have an h tacked on to my x? No, so that would be 0. Do I have anything added or subtracted behind my x squared? So that would be 0. So I'm still at 0, 0. But remember, we can't have fractions or decimals. Okay? So we're going to go back to our calculator. I clear it, doc B, that's the easiest to get rid of the current graph and to start a new one. So I'm going to do doc B, and then I'm going to type my negative. To get a fraction, if you don't already know, you do control divide. And then you can type your 3/4 x squared. And then I'm going to do control T, and I'm going to look at my 0, 0. And I'm going to verify that that is my vertex. How do I verify it's my vertex? Those y values repeat. Okay? Can I use -1 in my table? No. So I'm going to skip it, and I'm going to use -2, -3. And I'm going to keep going until I get the next whole number for my y values, which is -4, -12. Okay? Then I'm going to go in the opposite direction. I'm going to get 2, -3, and then 4, -12. Are good with that? Okay. So then, my next example, I've got 1/2 x squared. Look at that and tell me what your vertex should be. 0, 0 again. So I'm going to go back to my calculator, and I'm going to doc B it. And this time I'm going to have a positive 1/2 x squared. So before I graph it, what direction should it open, up or down? Up. Very good. Okay, and so for my table, what points am I going to use? -2, 2, and -4, 8. And then go in the opposite direction, 2, 2, and you should have 4, 8. Okay? So it's easy when you have the graphing calculator to give you your table for you. 2 things to check. Make sure those y values, again, repeat around that vertex. Next lesson, we're going to have to do it without the graphing calculator and build the table on our own. So make sure you understand that when you have a fraction for your a, you're really going in multiples of that denominator. Now, we didn't have to do jumping by 4 here because it's an x squared. So jumping by 2's is going to end up giving you jumping by 4's, because when you square 2, it gives you a 4. So just be careful when you're building that without the graphing calculator. Okay? Alright, now all of it combined, we're going to build the table, graph it, and identify all the characteristics. Okay? you can do it in this order. I like to build my table and graph it first and then answer all my questions. Okay? It's just easier for me. And it makes sense that way. So if I'm looking at my function, I've got y equals x minus 1 squared minus 5. What's my vertex going to be? 1, negative 5. Remember to change that sign for your h. Okay, so then I'm going to go to my calculator, clear it, and then I'm going to have my parentheses, which is next to 0, if you didn't already know that. Squared minus 5. So what you type should look exactly like what is on your paper. Okay, and then look at your graph. Is 1, negative 5 your vertex? In the general area, yes. So I'm going to go to my Control T, and I'm going to look at my points. Do I need to skip any x values? No. So I'm going to copy down 0, negative 4, and negative 1, negative 1, and 2, negative 4, and 3, negative 1. Okay. So then I'm going to plot those points and draw my parabola. And once I graph it, I'm going to answer all my questions. So my first question says to state the vertex. That's everything up here. We're going to go in order of this now. So my vertex, we said, was 1, negative 5. Then the axis of symmetry, we can abbreviate AOS, axis of symmetry. And I said that's always going to be x equals the x value of vertex because it cuts that parabola in half. So it's x equals what? 1. And we're going to graph that. Every single graph, it's a dashed line that we're going to graph. Okay, then we're going to identify if we have a maximum or minimum. Okay, so is my vertex a maximum highest point or minimum lowest point?
Minimum lowest point.
It's a minimum, so it's a minimum at, I abbreviate that, MIN. You don't have to write the full thing. A minimum at y equals what? What's that lowest point? Negative 5. We'll continue when y'all get back from lunch.
You shift to the right.
Shifts right
Like 1 unit.
1 unit. And
And it shifts like 5 units.
Shift down 5 units.
down 5 units. Very good. Okay, so then after you do that, we're going to do our domain and range. Okay, so your domain, it's a continuous function, so it's all real numbers. You can either do the negative infinity to positive infinity or your set builder notation for your XER. Okay, for my range, we said we had a minimum. So that means it doesn't go any lower than this point. So, so what is my range?
-5.
Like negative
Block.
5, comma, negative 5 is normal infinity.
Positive infinity.
Normal.
Okay, if I were doing set builder notation, I'd have y is what? Greater than or equal to -5. Okay, again, you don't have to do both. You can do whichever one you're comfortable with, but I'll write both so that you can see whichever way you need to. Okay? You're good with that? Okay. Example 4, we start with our table. What's our vertex going to be?
3, 0.
3, 0, because remember it's the opposite sign, because your formula is x minus h, so your h is the opposite sign. Go to the calculator, doc B. So type it in exactly as you see it. Control T to go to your table. And then you can verify that 3, 0 is your vertex. So I don't have to skip points, so I'm going to copy down 2, 1, and 1, 4, and 4, 1, and 5, 4. Okay, then I'm going to state my vertex, which we said was 3, 0. You don't have to write vertex out. You can just put the V. And then our axis of symmetry. Axis of symmetry is always going to be what? X equals, and then for this problem, X is going to equal 3, and so I'm going to draw that vertical line that's dashed, passing through the vertex. And range, domain is going to be negative infinity to positive infinity, or I need a new pen. Okay, what about my range?
It's going to be thing, 0, infinite, parentheses.
Okay. Very good. Either way is good with me. Okay? Any questions? All right. So example 5. We have our table. What's my vertex?
2,
Negative 2.
Negative 2 and -5.
Negative 2, 5. Go and type that. Remember, control divide will get you your fraction. Okay, in your table you get decimals because you've got a 1/4 in your equation. So I'm going to skip that -3 and I'm going to use -4/4 and -6/1 and then go in the opposite direction and 2/1. We good with that? And if you know you already have to graph the axis of symmetry, you can do that. You don't have to wait until you write it down to graph it. Okay, so we're going to state our vertex is -2, 5. Our axis of symmetry, we drew it, but what's my equation?
It's gonna be -2.
Very good. Do I have a max or a min?
Max.
At?
Y = 5.
Very good. Okay, for my transformations, left to right, what's this negative tell me? It's a reflection. Okay, what does this 1/4 tell me?
Shrink.
It's a vertical shrink. I was going to have y'all do by a factor of, but I didn't have my last class do that, so we're not going to do that. Okay, we'll just say vertical shrink. Okay, this +2 tells me it shifts and then the +5.
Shift right.
Are y'all good describing your transformations? Okay. All right, domain. All right, now my range this time. We said we had a maximum, so that means that's my top boundary. I no longer have a bottom boundary. So that means if I go bottom to top, I'm going from where?
Infinity.
Very good. -infinity to 5. Or if I'm doing set builder notation, y would be less than or equal to 5. Do y'all understand it?
Yeah.
Y'all are good to not do number 6?
Yeah.
Great.